Hello, everybody. Thanks for being here. It's great to see this full room. My name is Andreas Pöschl. I'm from BMW, and actually I was giving talks at SUSECON's BrainShare since 2008. It was a long journey. So we had classical infrastructure, and now we are moving on to cloud and edge. And today I try to give you some examples what we are doing there, why we are doing that, and it will be stories. Actually, it's not about detailed setups, it's not about detailed configuration, it's about the why and what are the use cases we are serving there. So before I was responsible for edge computing and container runtime, I did OpenStack. Before that, I did Linux solutions and architecture, including Xen virtualization and stuff. So also I personally went through this whole journey from Unix, HPX, I forgot HPX, Linux, /9 SP1 back then, introducing fiber channel adapters in Linux, moving on to OpenStack, totally different way of using infrastructure, and now we are doing cloud and edge. But we still have got, of course, a big classical footprint. So we have got lots of data centers around the world. We have got 2 data centers in each plant. We have got regional data centers in Munich, in the US, in China, and so on. We have got around 25,000 operating system instances, Linux, Windows, VMware, 200 petabytes of storage, SAN, NAS, and so on. So it's still a big footprint. But the world changes, and the customer would like to do something different. So at the moment, we have those typically managed services. Central IT takes care of infrastructure, period. Customers change. They would like to do it different, and not everybody loves central IT. I don't know how it is in your organizations, but central IT is slow, expensive, they are against everything. And so customers try to do it different. But for us, it's necessary to do it in a certain way, because we are operating the business critical workloads. We have got production, we have got sales, we have got dealerships where we distribute the parts. We have got a bank, BMW Bank, so it's a regulated environment even. And therefore, there are all the processes. But nevertheless, we wanted to change and we had to change. And 3 years ago, we decided that we will have a cloud-first strategy. Before, we accepted that somebody goes to cloud, uses cloud, but then we said cloud first. Because if we do it just a little bit, you actually double the cost. Because you have things in public cloud, you have things on-prem, you don't get rid of anything, and therefore you have got a lot of cost. We need to do it completely different. And we are pushing the applications towards public cloud. Some of them wanted to go to cloud. As I said before, they wanted to do it their own way. So they were already in public cloud even when we didn't want them to go. And so we created some guidelines. We had pure guided and managed service. It's a responsibility level. So if somebody just wants to go to cloud, do his own thing, that's pure, but you're on your own. You have got the full freedom and the full risk. If we provide some templates, if we provide best practices, tools around that, that's what we call guided. It's easier for them. They can still modify it a little bit, but they have to operate it on their own. So in operations, they are responsible for it. We just help them by providing the tools. And we have got the managed service where we take care of everything, and they just consume the service as they are used to from the former setup in the classical world. And while pushing those applications to public cloud, things change. DevOps, everybody knows, you have to change the way you're developing and operating. But during that migration, we also found out that we need to take care of the business more. So we have Biz, DevOps. Maybe someone was in the keynote last year. You know what's coming? So during that journey, security, we're going to public cloud. Things change. So we have to build in security from the very beginning, not later, because afterwards it's too late. So we're at BizSec DevOps. And now we saw this is going to be expensive. You better take care of finance too, make it cheaper, adjust the architecture, and now we are at BizSec FinDevOps. I don't know what's coming up next, but it is a very huge ecosystem, of course, so you have to learn to deal with it. As we are pushing customers, gently or less gently, depends, to public cloud, some of them wanted to stay on-prem because they are used to that. They would like to know that my service is running in the plant data center. But if you allow them to do that, that's against the cloud-first strategy, and they will have a lot of applications just staying on-prem without the real need. And this is why we have clear rules when you're allowed to stay on-prem, on edge, and these are latency, if you have got extreme latency requirements, if you have got high data volume, which is actually a cost decision, because if you insert enough coins, you can transfer any data volume to public cloud, but it doesn't make sense at a certain amount. And the third thing is data sovereignty, regulations, but that's usually the weakest point. With latency, you cannot do anything against that. If low latency is required, you just have to stay on-prem. Data volume depends on the cost. And there are some reasons, like it would be too complex from an architecture perspective to have a little service in cloud and going back and forth if it just doesn't make sense. And to make sure that we have got these reasons at an application, we do an onboarding call. We did that already with OpenStack because a lot of people wanted to use that cool service. I can do everything there. So we have got an onboarding call where we check if the workload is ready. We don't let them do lift and shift. If you migrate to cloud or edge, you change your architecture, period. Because if we start doing lift and shift, we will have the same mess as before. So they have to have the appropriate workload. They need to have the appropriate mindset. Do you understand that you are responsible for the architecture, that you need to take care of scale out, you need to take care of redeploying? And if the mindset is okay, do you also have the skill yourself, or you have got a partner who can do that? And if this is valid, they could stay on edge and we will help them to implement that. So, what is edge? If you just put servers in the data center in the plant, that's not edge. So, as I said before, it has to be changed in architecture. And what we implement is a Kubernetes ecosystem based on Rancher, Harvester, Longhorn. And if you migrate to edge, you have to go on Kubernetes, actually. Also, the term edge, when you talk to customers, nobody really understands what edge is. It's the on-prem thing. Or is it not cloud? Near edge and far edge, nice term, but it always depends on who you're talking to, because the guy in the plant says, yeah, this is near edge, and over there is far edge, and the cloud guy says the other way around. So you need to make sure that you have got the right terms. So we call it enterprise edge and industrial edge. Enterprise edge is the data center part, the Rancher, Harvester, Longhorn, Kubernetes ecosystem, and the industrial edge is industrial PCs and when it goes directly to production. because also there you have something, but that's typically not in the responsibility of central IT. I don't know how it is in other companies, because that's done by the business. And those guys have got own ways of doing things. But I'll come back to that later on. So I believe in edge as a kind of niche market. It will not be the masses like cloud. If I have a look at the different applications, probably the majority will go to cloud, and it should be. Because there we've got all the services available we would like to have. We don't have to implement that. And even if the infrastructure cost is a little bit higher, we as infrastructure guys usually always compare the infrastructure cost. But for the application, it's more important that the overall service cost is less than on-prem. So we have got cloud as a big part, edge more as the niche market, but very interesting, very critical, demanding customers, and absolutely cool use cases. And today I would like to share some of the use cases because they are so cool. Yesterday, I don't remember who I talked to. I even got goosebumps when talking about, right. So it's amazing what we can do in edge, what you're doing there, but it's a different world, to us at least. So what we also managed when going from classical infrastructure to edge is, I said we have 2 data centers in each plant, and asked the data center team to get a 3rd data center. We tried that for 25 years, and it didn't happen. And suddenly they understood, yes, Kubernetes is there, and we need 3 data centers. It's not a big data center, but you have got 3 locations, so you could set up Kubernetes properly. That's amazing. Finally, we needed some other prerequisites like SDN, because the classical network structure with 2 core switches doesn't work with 3 data centers. So we modernized also the backend infrastructure, because everybody was understanding that this is a new world. We have to change, we have to go forward, and we are totally happy that we have the opportunity now to bring in these new technologies and the new concepts. I think that's it so far on the basics, on the background, and let's start with use cases. We are migrating our production software infrastructure to public cloud. That's a really big step. And it's not just one application, of course. I think there are 300 something applications in that ecosystem, and it will take us roughly 10 to 15 years to migrate that, because it's intertwined so closely. You cannot just migrate the part off. And you better be safe. There's no time for being sorry here. So what we also have in this OT world, the operational technology world, is those guys speak a different language. We had workshops with them to learn about their requirements, their needs, and the first 1.5 days we just built up a glossary because we talked about totally different things. If you ask them what an asset is, it's different from an IT asset. And also when it comes to service levels, do you need a change? Problems? What's a problem? They don't have those processes. They have got their own processes, but you have to kind of align that. And now we talk to them, and one of the challenges is you have got the PLCs out there. And PLCs are different. They have got very limited resources. And if you try to connect to a PLC with 50 applications to get some data in and out, that's not going to work. Those PLCs talk old, mature protocols. RFC 1006, for example, no authentication, no authorization, no encryption. If you connect this world to public cloud, that's not going to work. You cannot just stream your data into public cloud without any security. We need to make sure that we have all the data available we would like to see in all the applications, because there are so many new use cases. coming up where you have suddenly ideas how to connect things and use the data from this step also in the next step. But if you try to connect the PLCs directly, that will blow up the software. PLCs have the cycle times. You cannot exceed that. So we built a system, a central connector for the production. And this is a layer which is slightly critical, of course, because it connects all the PLCs, all the systems in production to public cloud. We connect them via message bus, and data goes back and forth, and this thing has to be up and running. And this is running on Harvester and RK2. That was the first step. But as soon as we had the infrastructure available in the plants, suddenly other applications also came up and said, we would like to work with you, and we would like to use this new technology. The difference is these guys are still central IT who are responsible for that part because they had the connectors to the application also before. They know our processes. They know what we are talking about. But the others, it took some time to understand what they really wanted. Which brings me to the second use case, one of the really cool use cases. It's called AFW. There's also some information on the internet on that. At the end of the production line, the car is driven off the production line and goes over some kind of bumpy road because they want to find out if there are some noises in there, some rattling, squeezing, and so on. The problem is people hear different. If you have got a cold, you don't hear everything. Different people, different quality, and so they wanted to improve that. They built a box, AI supported, where they had a baseline spectrum of the noise, and they put it in the car, and when you drive this small piece of road, the device tells you there's a noise. It cannot tell exactly where it is, but if there's a noise, you just drive the car into some rework area. If everything is okay, you go to the parking lot. Works great. Better than all the people driving the cars. And the only problem is, if you have that box in the car, there's the driver. The driver breathes. The driver sneezes. The driver moves. So next step, you need to get rid of the driver. That means the car needs to drive on its own. And you might think, autonomous driving, that might be a thing here. Not all the cars have got the equipment, the sensors, the software for autonomous driving. Also, map material of the plants, not that publicly available. And the sensors for autonomous driving have to be calibrated on the first kilometers. And after that, you can drive autonomously, but not at the very beginning. So we needed to find a different way of doing things. And the business, innovative as usual, made some POCs, and they built some LiDARs, those laser and camera systems, along the production area. And the LiDARs have a look, where are people, where are the cars, where are boxes, where are the logistic vehicles, and we create an environmental model out of that. Currently, we are at, I think, 100 LiDARs. We'll scale up to 300 or so. And each LiDAR has got 80 to 100 megabit per second data stream. You are not going to stream that just raw into cloud. So you need to work on that data on edge. That's a typical edge use case. We found out it's edge plus because it's it's a little bit harder than expected. But that's a typical edge use case. So we create an object stream kilobit per second out of that LiDAR data, and that is fed into public cloud. There's a motion planner, and the motion planner controls the car. Actually, there's a remote-controlled car driving in the plant off the production line. And I've got a small video on that. There's no sound, intentionally. So you see the cars are without drivers. And this is how the object detection works. That video is already, I think, 1 year old, early stage. They can go up to 28 kilometers per hour. They usually don't do that, except you want to intentionally hit someone. And one of the challenges is also if this thing is driving automatically on its own without driver, you need TÜV certifications, you need to have safety systems. We have this object detection on one side, and we have got a separate set of servers with special safety software that is also used in train stations, airports, to make sure that there is emergency brake capability. But this automated driving in the plants is one use case where we found out virtualization is not always good. So it was just not capable of dealing with the network traffic. And now, in parallel to this virtualized environment, we are now also providing a service based on bare metal servers. Still RKE2, still managed by Rancher, also using Longhorn, but leaving out the virtualization layer. And this is how usually edge evolves. You've got a problem, and they told us 3 days before going live in the first plant, it doesn't work. Because they didn't test earlier with the full amount of LiDARs, and we need a fix. And edge moves fast. Compared to the classical solutions, edge moves fast. And we don't know where we end up. Because they are so creative, they come up with new use cases nearly every day. Another use case. It would be cool to have a system that tells you where every car, tool, and so on in production is. Because sometimes you have got relations like there are screws who have to be tight with a certain torque. Regulatory, 35 Newton meters here, 100 Newton meters there. Different tools, different screws, or same tool, different screws, different torque. How do you make sure that the right torque is applied? And we've got a system that is a kind of indoor GPS. We track all the systems, and there are a lot of sensors, a lot of RFID and other technologies to track where is which system. And whenever a worker takes a tool off the preparation area, we know which tool he has got and to which screw he is going to. And you can apply the configuration to the tool, which torque to use, for example. And you can, if it goes to the wrong screw, it doesn't work. If you go to the right place, it's applied. And you can also make sure for documentation, yes, it has been done. The problem here, it's also throughput. And we started out with classical software, but we are also transforming that to edge now, because that's a typical edge use case. We have got this OT world out there where you talk to some devices, and knowing where the things are, that's actually a use case which is expanded nearly every day. One of the problems, they just add sensors and suddenly it breaks again. Because regarding testing and change planning, the OT guys have got different ways of doing things. But we're learning there. Another use case, it's called AIQX, AI-based quality control. It's based on vision mostly, but also some other data. X stands for different ways of having the sensors. There are a lot of steps in production where you would like to know if they are done correctly. How to check that? How to check if a sticker is placed correctly or a sticker is placed at all, because there is some regulatory requirement that for some countries you need this airbag sticker at the right place. How to make sure the sticker is there. How to make sure that there are washers at a screw, that the worker didn't forget that. In the past, we had people checking that. Now we have got AI-based systems, and these systems currently train the models in public cloud, because there we already have got the machine learning algorithms, we have got the services available, and we train the models there and also do the inference in public cloud or sometimes on industrial PCs with GPUs. But as the use cases evolve, those industrial PCs will become too small. So these will be use cases which probably move into this enterprise edge soon. At the moment, still spread between cloud and far edge, industrial edge. So we have got cameras all along the place, which take pictures and videos of the cars passing by, and knowing that I have to look at these pieces like screws in the door frame. We had a discussion on that yesterday. But we have got data privacy laws. What if a worker comes into the vision field of a camera and it's recorded? Even if you don't see the face, the worker might have tattoos. So you could recognize that person, and that's not allowed. So the system does real-time blackening of the part where a human is. I will show a video soon where you briefly see that you don't see the people anymore, it's just black frame. So you have to take care of so many things, and the goosebumps again. Oh man. Other topic, also shown in the video, BMW has got this hazard triangle, emergence triangle, which you put on the streets after an accident, in the trunk. Somebody puts this device in the trunk. How to check that it is really there? Cameras, of course. Where to mount the cameras? Business was creative again. Behind every trunk, because the cars move along with an open trunk, and the next car has got a front camera in there. So now we are connecting not only IT and OT, we are also connecting it to car IT, and we use the front camera of the car, because it looks exactly at the open trunk, to check if this device is mounted there. And I think I just show the video until it's... Is the position of this sign correct? AIQX. This is the data protection, and this is done in real time. If you Google for AIQX, you'll probably find some information on that too. And this is the front camera. Positioning of the cars in the production at the parking lots, now combined with this automated driving in the plants, you can now drive the cars directly at the parking lots. You don't need special equipment in the car because the LiDARs and the motion planner, the central system takes care of that. So there are a lot of cool use cases. One of the problems is network. What about the network? We have got different approaches. Yesterday in the session of Bosch, they have got a strategy to keep the plant ecosystem together. In our case, we separated, we put stuff in cloud first. That gives you additional risk because you don't know what happens there. And up to now, we had a quite Munich-centric network infrastructure. Plants were usually connected to Munich because that was the back-end systems have been there. That was the central location. Now when we go towards public cloud, we need a different approach. And our networking guys change everything to what we call internet-centric backbone. So now all the plants change their network connection from plant to the next public cloud endpoint or public cloud data center. You can rent rack space close to the public cloud rooms where you can put your own hardware, some Equinix data centers or edge centers, I don't know how they are called exactly. So now we connect all the plants directly to the public internet providers, which in our case is Amazon and Azure. We use both. And this enables us to really leverage the full power of cloud while still having some really cool use cases in edge. And this is something where we will probably see additional solutions. We are playing around with GPUs now. As I said, the PCs will be too weak soon, we expect. We will have extremely high requirements regarding performance, so also virtualized and bare metal service, and we expect real-time applications, real-time requirements soon, because as soon as the OT world opens up to IT and the other way around, we will have so many new use cases, which you can only handle if you can deal with these real-time requirements, near real-time requirements properly. And that's it. Do you have questions?
Yeah, I do have a question. When are we going to go to the cloud? No, that's a real question. If it's been so successfully in this, are you planning to extend that use cases into more traditional, like data center and all of that stuff?
So the question is, as we were so successful in this edge implementation, are we going to extend these services to classical infrastructure, data centers? If somebody would show up and says, we need Kubernetes in the classical data center, we might say yes, of course, because it's a customer. But actually, what would be the reason to do this on-prem in a classical infrastructure data center or classical infrastructure environment? If it's really classical infrastructure from a requirements perspective, that application could go to public cloud. So we would rather migrate that application to public cloud.